All right, good afternoon and welcome to our science virtual meetup. If you're watching this video, that probably means you couldn't attend, but you could also be watching this video if you need a review. So either way, I'm glad that you're here. If you were not able to join us for our virtual meetup, I hope that you come next time. It's really important to be there, guys, so make sure you're trying to come. Okay, our welcoming ritual for today. I want you to pick one and answer it, okay? So you can either choose the top question to answer or the bottom, okay? So the first one says, tell us of a time you baked something. What was it? How did it turn out? What process did you go through to bake it? Okay, so that's the first one. And the second one is, put on your chef hat. Today you get to bake whatever your heart desires. What would you bake? How would it turn out? What process would you use to bake it? Okay, so talk about one of those to someone around you. It could be a pet, a family member, okay? Choose one of those things and talk about it now. Okay. So today we're going to be talking about physical and chemical properties and physical and chemical changes. Okay, so we're going to start out with our I can statements. Our I can statements for today. Number 1, I can explain the difference in physical and chemical properties. 2, I can explain the difference in physical and chemical change. And 3, I can provide evidence to support whether a change is physical or chemical. Okay, so we're going to be going into that a little bit more today, and hopefully by the end, you're going to be able to know these 3 things very well. All right, we're going to start off with talking about properties, and this should be a refresher because we actually have already taken a test on this. Okay, this is just to get our brains remembering what a property is. So, a property is a description of an object, right? So, we had talked about color, texture, the temperature. Those were different properties, okay? And we talked about how some were measurable and some were observable. But today we're going to be talking about whether they are physical or chemical, okay? So, we've already talked about observable and measurable. Now we're going to be talking about physical or chemical, okay? So here are some things that we notice about this little money tree, okay? First, the tree is green, okay? So that's something that we can notice about the object. It describes it. The tree is also tall. Now, it looks small on your screen, but we're going to pretend this tree is tall. And then the last one, if struck by lightning, the tree could catch fire and burn, okay? So that is something about this object that it could burn, okay? But it's not something that we have talked about yet. So I want you guys to keep those kinds of things in mind, okay? The color, the length, the mass, the volume, okay? Those are some things that we have talked about. And then we're going to be talking about some other things like burning, rusting, things like that. So a physical property. Physical properties are determined by the use of the 5 senses, okay? So, all physical properties can be determined by 5 senses, which are sight, hearing, touching, feeling, right? Touching and feeling are the same thing. Smelling, tasting. Now, before we go any further, it's really important to note that we don't want to taste things in our science lab, right? Because some of the things we would be allowed to taste, right? If we were making a chocolate chip cookie for an experiment, we'd be able to taste that. But other times we're using chemicals, and that's not a good thing to try to taste. Okay? So all of the physical properties, we can use a description of the 5 senses, to determine that. Okay, so like color, smell, taste, hardness, state of matter, okay? And let's talk about really quick, what's a state of matter? What does that mean? We have talked about this. What are the 3 states of matter? Okay, hopefully you said gas, liquid, and solid. Those are the 3 states of matter. Okay, and that is a physical property. And then also boiling, freezing, or melting point. Okay, because that's the different states of matter, right? That's how it changes. Okay. Examples of physical properties. Ooh, we've got density and mass. So we haven't talked about density, but that is one. Mass and volume, which are 2 that we have talked about. Remember, mass is the amount of matter in something, and the volume is the amount of space that the matter takes up. Malleability, the ability to be molded. Okay, so if you take a mallet or a hammer and smash a metal, if it's easy to smash it down and make it into a sheet of metal, it's more malleable than if it weren't as easy to smash it down into a sheet. Solubility is the ability to be dissolved. And so that is in water. If you were to put sugar in water and stir it around a bunch, how fast the sugar dissolved in the water would be its solubility. Okay, now chemical properties. So this is a new one, so turn your listening ears on all the way. They are determined by a substance's ability to react with other substances. So it's all about the reaction. Okay, so this says the ability to react with air, which is true. It forms things like rust, tarnish, corrosion, it corrodes, and let's see if it clicks. And when something rots. Okay. Also the ability to react with water or acids, okay? The ability to catch fire is flammability, okay? So we kind of talked about that in the beginning, how likely an object is that it would catch fire and burn is its flammability, okay? So when we think about chemical properties, we are thinking of reactions, okay? And we'll go a little bit deeper into that. So let's just test this out, okay? I'm going to give you a few, and you pause the video and decide whether you think it's a physical or chemical property. Remember, physical property is something we can observe with the 5 senses. A chemical property is something that's changing in the chemicals, okay? Something that's changing in the chemicals. So let's read this first one. The ability of gunpowder, and fire to explode, okay? So when those 2 are combined, they explode. Now, before you answer, you might say, oh, well, I'm able to see that. Yes, you are able to see it. But what's happening, okay? What's happening to make you able to see it? Okay, so hopefully you said that something had to change in order for it to explode, right? The fire had to come in contact with the gunpowder, which caused a chemical change, okay? So that's a chemical property, is the ability for it to explode. What about the color of a sunset? Physical, right? We can see that. The ability of a nail to rust. Okay. the ability of a nail to rust, is a chemical property. The shape of a leaf, that is a physical property. The ability of wood to burn. So we talked about this before. That's flammability. That is a chemical property. The hardness of a diamond. Is that something you can observe with the five senses? It is, right? So it's a physical property. The volume of your Coke. The volume. Physical, right? Mass and volume are physical properties. No, and let's go back to that. No, when I pour that Coke from the Coke bottle into the glass, none of the chemicals are changing. They're staying the same, right? It's just going from one bottle to the next, okay? Which shows us that the volume, right, the amount of liquid, the space that it takes up, is going to change based on the container it's in. But the chemicals aren't going to change. You're still going to be drinking Coke, okay? It's not going to turn into milk when you pour it into the cup. All right. Physical or chemical property. The mass of 2 camels. Oh, and I just gave you a hint for this one. Physical, right? Physical property. All right, and we're going to skip that. If you were in class, you'd be able to take the poll with us, but we're going to skip that and keep on going. Okay, so what's a physical change? It's a change that occurs without changing the identity of this substance. No new substances are formed, okay? So you might be thinking, why is this picture here? Okay, well, this is a picture of what? Hopefully you said makeup, maybe you said girl putting on makeup, okay? So the reason I put a picture of makeup on this slide is because I want you to remember that what makes up the object doesn't change, okay? The makeup of the object doesn't change, which means that the chemicals inside it don't change, right? We're saying all those chemicals are staying the same. It just might look different, but the chemicals are staying the same, okay? Nothing new is formed. For example, ice and water, right? When ice turns into water when it melts, that is the same chemicals. It's still water, whether it's frozen or not. It's not changing into something new because it melted. Okay, and that would be a physical change. Here are some examples of physical change. Change in size, change in shape or color. So like pencil shavings, right? They started on the pencil, but once you shave them off, that's going to be the same chemicals that was in the pencil, okay? As the same makeup. What about torn paper? Okay, if I have a sheet of paper and I tear it all the way down the middle in half, I'm going to have 2 sheets of paper now that are both smaller than the first, but what that paper is made of stays the same. I could still draw on the paper. Crushed ice, sugar dissolved in water, painting on a wall, okay? Chemical change. So this is a change that occurs that causes the identity of the substance to change. Something new is formed, okay? So this, the makeup of the object is changing. What it's made of is changing, okay? So it's a new substance with new properties, okay? And we see over here, we see the batter for the cake, okay, before it's finished. And then we see the finished cake. Now, I bet you know that the batter is not the same thing as the cake, right? If you were to eat a bunch of batter, it would not taste the same as a cake, okay? Some of the chocolate might taste the same, right? But what happens is when you mix up all those things, it causes a chemical change when they're baked together, okay? And it makes that cake rise up and become fluffy, okay? It turns fluffy when it was once gooey, right? So that is a chemical change. So think about that thing that we talked about in the beginning of when you made something in the oven. Did yours have a chemical change? Did it go from gooey to fluffy? Okay, so think about that. So some things that show us the evidence of a chemical change are it turns into a new color, okay? And so sometimes color is a hard one, right? Because we already said color is physical, right? So how can it be chemical and physical, right? Well, let's explain how it can be chemical and physical. When we were talking about physical properties, right? So what we are observing with our eyeballs, that is chemical, or that is physical, right? That's the physical item is orange, right? If I had an orange and I was eating it, that item, its physical property is orange. But what about, what about if I mixed two liquids together, okay? So I mixed two liquids together and I had a blue liquid and I had a white liquid, okay? And I didn't know what these liquids were, but I mixed them together in the blue and white liquid. It made purple somehow. So I know that something had to happen in those chemicals to make a new color. Okay, and that's what we're talking about when we talk about chemical change. We have the bubbles that might appear, which bubbles let us know that there's gas forming. Okay, so that's when something might fizz. Precipitation forms on solid matter, which if you know what precipitation is, that would be a liquid forms on top of the solid. If heat is produced, okay, so if when you combine the two things, it makes it heat up, okay, that tells us that the chemicals are reacting with each other. Also, if light is produced, sound is given off. And it's difficult or impossible to reverse one of these changes, a chemical change. If we looked back, which I'm not going to click all the way back, but if we did, and we looked at those physical changes, we can turn water back into ice, right? That's pretty easy. All we've got to do is put it in a bowl and put it back in the freezer, right? And it turns back into ice. These, once you've got them, they're not going back, okay? So think about that cake that we talked about. Once you've baked the cake, can you make it back into batter? You can't, right? It's undergone a chemical change, okay? So here's this little one. Here's a reaction with acid. Okay, so vinegar plus baking soda, and we actually already kind of watched this. But the baking soda is a solid, right? It's that powder. And the vinegar is a liquid. But once they're put together, they release a gas, and that's what fills up the balloon. Okay? We have oxidation or rust, okay, which is iron plus oxygen. That equals rust. So it's that color that you see on nails that have been out in the rain maybe, or that are really old, okay? It's when iron is mixed with oxygen, okay? That creates rust. And obviously that orange color is the chemical change that we see. Electroplating, so this is done with electricity. And this one, we're not going to go too deep into, but basically they use electricity, okay, to create a new substance. They put silver on top of another metal by using electricity. Reactions between substances. So we can see the tarnish of these silverware down in the corner. Okay, that's silver plus the sulfur in the air. Other examples are wood burning, metal rusting, food digesting, okay, all the acid in our stomach breaking up that food, gasoline burning, or a cake baking. Okay, so let's think about these for a second. You're going to decide whether you think they are physical or chemical changes. So what about number 1? Water evaporates from the ocean. Go ahead and pause this video. Try to explain why it's a chemical or physical change, okay? So I want some evidence. Okay, so evaporation, right? That is changing states, okay? States of matter. It's going from a liquid to a gas, okay? But what it is doesn't change. It's still that water. It's going from a liquid to a gas, so it is a physical change. What about this one? The yolk of an egg, which contains sulfur, causes tarnish to form on silver. So that yolk, if I put it on silver, it would cause tarnish. Hopefully you said chemical change, right? It can't go back once it's tarnished, okay? It can't, unless we use other chemicals, it's really hard to get it back to the way it was. Physical or chemical change. The ice on a lake melts to become water in the lake. You guys should know this one. It's physical change, right? The melting is physical change. Charcoal in a fire turns to ash after several hours. Okay, this one might be a tricky one, but think about what you know about chemical changes and physical changes. When do we talk about burning? Is it with chemical or physical? Burning is a chemical change, so this would be a chemical change. Physical or chemical change. A pencil is sharpened in a pencil sharpener, leaving behind shavings. It's a physical change, and hopefully your evidence that you said was because the pencil shavings don't change what they're made of. They're made of the same thing, but it's just off of the pencil now, right? It's in a different shape and form. Physical change or chemical change. The battery makes electricity to turn on a flashlight. Remember what we said about when light is produced. That was one of the last things we talked about. Okay, so that would be a chemical change, okay? Light is produced. All right, a bicycle rusts when left in the rain. Is rust a chemical change or physical change? It is a chemical change, and we can see that by the color. A shirt is accidentally torn in the washing machine. Physical or chemical change? That would be a physical change. The shirt stays the same. It's now just a different shape because it's been torn. A log is split in two by an axe. Same thing, physical, right? Because of that change that we see. That is not caused by it being any different, right? It's the same substance, but now it's in 2 halves. So before we go today, I want to ask you guys, we're going to go, let's try to go back to the beginning for a second. We're going to go back to our I can statements, okay? Okay. I want you guys to answer one of these. I want you to either explain the difference in physical and chemical properties. Okay, so you can explain the difference in what the properties are. Or explain the difference in physical and chemical change. Or tell me a way, provide evidence to support whether a change is physical or chemical. Okay, so give me an example and tell me how you know. Okay, so I want you to pause this video, and since you can't actually tell me, I want you to tell someone around you, maybe a pet, family member. Go ahead and pause this video and share that with them. Okay, great job. You guys did great today, and hopefully I will get to see you very, very soon. If you weren't at the virtual meetup, I can't wait till next time I get to see you. So keep doing your best, okay? There is an exit ticket, so be sure to go into Science and click the exit ticket for today. All right, I will see you guys very soon. Bye.